There's a region on the map of Russia that you simply can't reach by car. Not at all. There's no road leading there. The Kamchatka Peninsula is cut off from the mainland, as if nature deliberately decided to hide this place from the rest of the world and forgot to attach an entrance. Kamchatka stretches about 1,200 kilometers from north to south. In terms of area, it's comparable to the entire country of Japan or the state of California. Yet, the overwhelming majority of people living in Russia have never been there, and likely never will. Not because they don't want to, but because the only way to get there is by plane or sea, and a one-way ticket costs as much as if you were flying to another continent. Technically, you are flying to another continent. It's just that formally, it's still your country. But here's what's truly important to understand about Kamchatka. It's not just a distant piece of land. It's a place where the Earth is still building itself. Right now, while you're listening to this, a process that geologists call subduction is happening beneath the peninsula. The massive Pacific Plate, a piece of the Earth's crust the size of half the planet, is slowly creeping under the Okhotsk Plate at a rate of several centimeters a year. Kamchatka sits precisely at the point where one plate is pushing under another. The result of this collision protrudes from the ground in the form of about 160 volcanoes, 29 of which are considered active right now. Before we continue, please subscribe to the channel and give a like. To clarify what active means, the Tolbachik volcano began a fissure eruption in 2012 that lasted almost until the end of 2013. Lava flowed across the land for dozens of kilometers, burning forests, burying trails, reshaping the landscape. Where trees once stood, there's now solidified black rock. And this isn't some event from a textbook. It happened just over 10 years ago, and the traces are still visible. The land there is literally younger than most of the people watching this video. The climate of Kamchatka operates under its own strict rules. The average annual temperature in most of the peninsula is below zero. This means that if you take all the days of the year and average the temperature, it will be negative. On the eastern coast, up to 6 meters of snow can fall in winter. Not centimeters, meters. 6 meters is the height of a 2-story house. In open areas, the wind can reach hurricane strength and blows the snow horizontally, making it sometimes unclear whether the snow is falling from above or flying at you from the side. And amid all this cold, wind, and volcanic rock lies one of the most incredible places on the planet, the Valley of Geysers. It was discovered in 1941 by geologist Tatyana Ustinova, and that's a story in itself, because she found the valley on foot during wartime, without satellite maps, drones, or any technology at all. She simply followed a stream and stumbled upon a place where boiling water and steam erupt from the ground at regular intervals. The Valley of Geysers in Kamchatka is the second largest geyser field in the world after Yellowstone in the United States. About 20 major geysers operate there at regular intervals, each on its own schedule. One erupts once an hour, another once every 4 hours, and a third once a day. Each time, a column of water and steam shoots up several meters, sometimes dozens of meters high, with a noise that can be heard from a kilometer away. In 2007, a disaster occurred. A powerful landslide struck part of the valley and buried several geysers under tons of mud and rock. It seemed they were lost forever. But time passed, and some of them broke through again. Through the rocks, through the mud, through meters of earth, hot water found a new way to the surface. When you read about this, it's hard not to start thinking of these geysers as something alive, even though technically they're just water and pressure. Do you know what connects all these facts? Volcanoes, geysers, snow, wind, isolation. They all create a place where life exists not because of comfortable conditions, but in spite of them. Kamchatka is a territory that tests all living things every day, and life passes this test. on a scale that's hard to imagine from a Moscow apartment or a Novosibirsk office. There are more than 14,000 rivers in Kamchatka. 14,000, that's not a typo. These rivers carry water from glaciers and mountain lakes to the ocean, and each one is an artery through which the life of the peninsula pulses. Water here isn't just a resource. Water is a transportation system, a dining hall, a maternity ward, and a cemetery all at once. Everything important that happens in Kamchatka occurs in or near the water. And to understand why this is the case, you need to get acquainted with one specific animal. Not with a bear, we'll get to that later. With a fish. With the most ordinary looking fish you've seen on a store shelf and maybe even had for dinner. With salmon. But ordinary is the last word you should use when talking about Pacific salmon. Because what this fish does every year in the rivers of Kamchatka, in terms of drama, biological complexity, and impact on everything around it, is rivaled only by what the volcanoes themselves do. Salmon is the engine that drives the entire ecosystem of the peninsula, and without it, Kamchatka would be a completely different place. For now, hold on to this thought. Somewhere on the edge of a vast continent lies a territory the size of an entire country, where no road can be built, where boiling water erupts from the ground, where volcanoes reshape the landscape every few years, and where so much snow falls in winter that it buries houses to the roof. And this territory is not a dead desert. It teems with life, because 14,000 rivers flow through it, and every year fish come up these rivers, triggering one of the most complex and beautiful biological mechanisms on the planet. Kamchatka is a place where fire meets water, where ice coexists with boiling water, and where life has found a way not just to survive, but to thrive under conditions that, by any logic, should have destroyed it. And the most astonishing thing is that this mechanism has been functioning for thousands of years without any human intervention. The only question is how long it can continue to operate now that humans have finally made their way here. In Kamchatka, there's a river named after the peninsula itself, the Kamchatka River. It stretches 758 kilometers across the entire peninsula, from the central mountain ranges to the coast, and it's so large that you can travel by boat on it for several days without seeing another person. But this river isn't even the most interesting part. In the south of the peninsula, there's Kuril Lake, and it's one of the main places on the planet where an event occurs that most people know too little about. Every year, up to 6 million sockeye salmon enter this lake and the rivers that flow into it to spawn. 6 million fish in one place is a sight that changes the expressions of those who have seen it in person when they start to tell the story. The water in the rivers turns red from the density of fish bodies. Not pink, not orange, red. Because by the time they spawn, sockeye salmon change color from silver to bright red, and when millions of these fish crowd into the riverbed, the river stops looking like a river. All 6 species of Pacific salmon inhabit Kamchatka: sockeye, chinook, pink, coho, chum, and masu. 6 species is a complete set, and there's nowhere else in the world where all 6 are present simultaneously in such numbers. The chinook is the largest of them, with some individuals reaching up to 45 kilograms, which is the size of a large dog. The pink is the smallest and most numerous, and it has the fastest life cycle. And here's where the most remarkable part begins. The reason why this story is worth telling. Every salmon is born in fresh water, in a river or stream. Then, after several months or years, depending on the species, it heads to the ocean. The pink salmon leaves and returns in 1 year. The sockeye lives in the ocean for 3 to 5 years. The chinook can roam the Pacific Ocean for up to 7 years, gaining weight and feasting on marine prey. And then, when the time comes, each fish turns around and swims back, not to just any random river, but specifically to the one where it was born. Scientists still debate how exactly salmon find their way home through thousands of kilometers of open ocean. One of the main hypotheses is that they navigate using the Earth's magnetic field over long distances, and as they approach their native river, their sense of smell kicks in, allowing them to literally detect the scent of the water in which they hatched, the scent of a specific stream, a specific rocky bottom, a specific mineral composition in the soil. Some species travel up to 1,500 kilometers upstream, against the current, over rapids, over waterfalls, without food, because in freshwater, salmon stop eating altogether. From the moment the fish enters the river, it lives solely off the fat and protein reserves it accumulated in the ocean, and these reserves diminish with every kilometer. But the lack of food isn't the worst thing that happens to a salmon's body during its spawning migration. When the fish transitions from saltwater to freshwater, its body switches to a mode that essentially amounts to controlled self-destruction. The kidneys start to function in reverse. Instead of excreting excess salt, they begin to retain it. The cortisol level in the blood, the stress hormone, skyrockets by dozens of times. And this cortisol does to the fish what it does to any living organism, but at an accelerated pace. It triggers the aging process. The immune system collapses. Bones soften. The jaws of males become distorted beyond recognition. A hump grows on their backs, and their skin develops white patches, a fungus that consumes living tissue, and the fish's body can no longer fight it off. A salmon that enters the river as a strong, silvery predator transforms into a grotesque, decaying creature by the time it spawns, barely managing to stay upright, or rather, afloat, solely due to a biological program embedded so deeply that even its own deteriorating body cannot override it. The female digs a nest in the gravel at the riverbed with her tail, lays her eggs, the male fertilizes them, and within a few days after that, both die. Not some, all. Every Pacific salmon spawns exactly once in its life and dies afterward. This isn't an accident, a disease, or a sad twist of fate. It's a biological plan honed over millions of years of evolution, and this plan has a very specific purpose. Here it is. 1 ton of dead salmon contributes approximately 130 kilograms of nitrogen and 20 kilograms of phosphorus to the soil. These aren't abstract numbers, they're fertilizer. Oceanic fertilizer that the fish accumulated in its body over the years, feeding in the most productive waters on the planet, and which it now gives back to the land. Each dead fish is a package of nutrients delivered from the ocean deep into the continent, hundreds and sometimes over 1,000 kilometers from the shore. Scientists from the University of Washington conducted a study that everyone should know about. Using isotopic analysis, a method that allows them to determine where a specific nitrogen atom came from, they found that trees growing along spawning rivers receive up to a quarter of their nitrogen from the ocean. Not from the soil, not from rain, from the ocean, through the bodies of dead fish. A spruce tree growing 100 meters from a river in Kamchatka gets nitrogen that the fish gathered somewhere off the coast of Japan or in the Aleutian Islands. The tree grows on fish. If you think this sounds fantastic, it's because nature is sometimes more fantastical than any script. But there's one problem. The fish dies in the water, the nutrients in its body are in the river, and the trees grow on the shore. How do nitrogen and phosphorus get from the water to the soil? The current might wash some organic matter ashore during a flood, but that's not enough to explain the volumes of transfer that scientists observe. Someone is needed to pull the fish out of the water and carry it into the forest. And that someone exists in Kamchatka. It's big, it's hungry, and there are a lot of them. In Kamchatka, there are between 15 and 20,000 brown bears, and their entire life revolves around the same salmon that drives the life of the entire ecosystem. The bear is the last link in a chain that starts at the bottom of the Pacific Ocean and ends in the treetops. Without the bear, the chain breaks, and the forest along the rivers begins to starve. But the bear isn't just a transporter of fish from water to forest. It's a complex, intelligent, and largely misunderstood animal that deserves a separate discussion. Its physiology breaks the rules that biology considered universal. Its social life at fishing sites resembles a small state with its own hierarchy, alliances, and conflicts. And its role in the ecosystem is so significant that scientists seriously use the term engineer when discussing its impact on the landscape. More on that later. For now, just think about this. The fish is born in a stream, goes to the ocean for years, swims thousands of kilometers, finds its way back by the scent of the water, travels upstream, destroying its own body, spawns, and dies, and does all of this for a reason. Its death nourishes the river, the shore, the forest, and every animal that lives nearby. This isn't a tragedy. It's a perfectly functioning conveyor belt, where death is not the end, but fuel for the next cycle of life. And this conveyor belt is still running. The only question is who maintains it at the Kamchatka end. In Kamchatka, there are between 15 and 20,000 brown bears. This is one of the densest populations of brown bears on the planet, and when you find yourself in those places, you realize this not from statistics, but from the feeling that someone is always watching you. Because most likely that's exactly the case. The bear sees you before you see it, hears you before you hear it, and smells you from kilometers away before you even suspect its existence. This isn't an exaggeration. A brown bear's sense of smell is several thousand times sharper than that of a human. The Kamchatka brown bear is smaller than its closest relative from Kodiak Island in Alaska, but larger than most other brown bears in the world. An adult male typically weighs between 350 and 450 kilograms, though heavier individuals can be found. For comparison, that's the weight of a small motorcycle with a sidecar, only this motorcycle can run at speeds of 50 kilometers per hour, climb slopes, and catch fish with its bare hands, more accurately, with its bare paws and teeth. But before discussing how the bear catches fish, it's worth mentioning what it does when there are no fish. Because for 6 months of the year, the Kamchatka bear hibernates, and what happens to its body during this time breaks several basic rules of biology. When the bear goes into hibernation, its heart rate slows from 40 to 50 beats per minute down to 8 to 10. Its body temperature drops, but not as much as one might expect, only by a few degrees. This isn't a deep hibernation like that of ground squirrels or hedgehogs, where the body practically shuts down. The bear is in a state that resembles a very deep, very long sleep, from which it can wake up in a matter of minutes if something disturbs it. And entering the den of a waking bear is one of the worst things that can happen to a person in the wild. But here's what's truly astonishing. During all 6 months of hibernation, the bear doesn't go to the bathroom even once. Not once. Its kidneys completely recycle urea, a byproduct of protein breakdown that is toxic waste for any other mammal, back into protein. The bear literally reprocesses its own waste into building material for its muscles. Any other animal, including humans, would die from urea poisoning within a few days if its kidneys stopped excreting it. But a bear does this for 6 months straight and emerges from its den in the spring hungry but alive. This mechanism is so unique that medical professionals working with patients suffering from kidney failure are currently studying it. If they can understand how a bear's body reprocesses urea back into usable protein, it could change the approach to treating kidney diseases in humans. A bear hibernating in a den in Kamchatka may hold the answer to a question that medicine has been trying to solve for decades. But hibernation is ending, and the season begins that makes this story worth telling. Salmon are heading into the rivers, and bears are gathering by the water. At Kuro Lake, the very place where up to 6 million sockeye salmon arrive each year. As many as 70 bears can fish at the same time, 70 bears in one spot, each weighing several hundred kilograms, each hungry after winter, and each needing fish. It's logical to assume this would end in chaos and constant fighting, but the reality is more interesting. Japanese photographer Shinichi Murata spent several consecutive seasons in Kamchatka observing bears at Kuril Lake, and what he documented turned the standard perception of these animals upside down. Bears at the lake recognize each other, not just distinguish, they recognize and remember each other for years. There's a stable system of relationships among them, with dominant males, subordinates, and neutral bears, and this system doesn't require daily confirmation through fights and conflicts. A large male occupies the best spot on the river, and the other bears do not contest it, not because they're afraid right now, but because they remember the outcome of last year's disputes. This isn't a pack with a leader. It's more like a community with a reputation system, where everyone knows who to avoid and who they can fish near. Females with cubs keep to themselves and stay closer to the periphery because large males pose a danger to the young. Young males try to find free spots on the river and sometimes get a beating from older bears for wandering into the wrong area. But overall, the system works, and 70 bears manage to fish side by side without turning the lakeshore into a constant battlefield. The fishing technique is a separate topic, and it shows that bears don't just grab fish randomly. At Kuril Lake, where the water is deep and sockeye swim beneath the surface, bears dive for them. They fully submerge their heads underwater, sometimes going so deep that only the hump of their backs remains above the surface, and they catch fish by feel, with their paws and mouths. At the rapids of the Ozernaya River, where the water is shallow and fast, they use a different technique. They stand on the riffle and catch sockeye in midair as they jump over obstacles. Research has shown that an experienced bear can catch up to 30 fish in an hour during peak salmon runs. 30 fish in an hour, that's one fish every 2 minutes, and when you see it on video, it looks less like hunting and more like a conveyor belt operation. The bear stands, the fish jumps, the bear grabs, the bear eats, or doesn't eat. Because here's what's most important for the ecosystem. When there's plenty of fish, the bear starts to be picky. It eats the most calorie-dense parts, the brain and roe, and leaves the carcass on the shore. And this moment is crucial for the entire forest around the river. The bear carries the caught fish an average of 50 to 100 meters from the water, sometimes further. It eats in the forest, in the bushes, in a clearing, and leaves what it didn't finish. Scraps, bones, skin, entrails, all of this remains on the ground and begins to decompose. Within a radius of this zone, 50 to 100 meters from the shore, the nitrogen content in the soil is 3 to 4 times higher than further from the river. Trees in this area grow faster, their foliage is denser, and their root systems are stronger. And this isn't a coincidence. It's a direct result of the bear acting as a courier between the ocean and the forest. But the bear isn't the only courier. Dozens of animal species join the chain of salmon organic recycling. Bald eagles, huge predatory birds with wingspans over 2 meters, winter in Kamchatka in numbers up to 2,000 individuals, and they all feed on salmon remains. Foxes drag pieces of fish to their dens. Martins, crows, gulls all get their share. And what's left after everyone else goes to hundreds of species of insects and bacteria that break down the organic matter into a form that becomes food for the soil. Scientists conducted isotopic analysis of the foliage of trees growing at different distances from spawning rivers and found traces of marine nitrogen, the same nitrogen that salmon brought from the ocean, even in trees standing a kilometer from the nearest water. A kilometer. The fish didn't swim there. The bear didn't carry the fish there. But the eagle that grabbed a piece of salmon by the river and flew off with it to a tree, or the fox that dragged the fish's head to its den deep in the forest, they completed the job. Oceanic nitrogen reached the farthest trees through dozens of paws, beaks, and jaws. That's how it works. The ocean feeds the fish. The fish carry the ocean into the river. The bear brings the fish from the river to the forest. Birds and animals spread the remains even further. Insects and bacteria integrate all of this into the soil. The soil nourishes the trees. The trees stabilize the riverbanks. The rivers provide a home for the next generation of salmon. And the cycle repeats every year for thousands of years. This isn't just a pretty diagram from an ecology textbook. It's a functioning mechanism where every part depends on every other part. And if you remove even one, the fish, the bear, the forest, the river, everything starts to fall apart. And this is exactly what we're risking right now. In 3 parts, we've talked about how all of this works. Volcanoes shape the landscape. Rivers carry water. Salmon bring the ocean to land. Bears distribute fish throughout the forest. The forest stabilizes the riverbanks. Rivers accept the next generation of salmon. The cycle is closed, and it has been running smoothly for thousands of years. But now it's time to talk about what could stop this cycle. And here the tone of the conversation changes, because the threats are not theoretical or distant. They're already here. The first and most significant threat is climate change, and in Kamchatka, it manifests not as abstract graphs, but as very concrete things that can be measured and felt. According to Russian meteorological stations that have been operating on the peninsula for decades, the average temperature in Kamchatka has risen by about 1.5 degrees over the last 50 years. 1.5 degrees sounds trivial. You wouldn't even feel that difference stepping outside in the morning. But for an ecosystem that has been tuned to a specific temperature range for millennia, 1.5 degrees is like moving the hands of a clock half an hour forward in the entire city and expecting trains to arrive on time. The glaciers of Kamchatka have lost about 20% of their area since the 1950s. 20% in 70 years means that ice that has accumulated over centuries is melting faster than it can build up. Glaciers feed the rivers, rivers host the salmon, and salmon nourish everything around. If glaciers continue to shrink, rivers will become shallower, and some spawning grounds will cease to function. Not all, not immediately, but the process is already underway. There's also a more subtle mechanism that's harder to notice, but could cause more harm than the shallowing of rivers. Warming water shifts the timing of the spawning run. Salmon are used to arriving within a specific window, say in July or August, depending on the species and the particular river. A mother bear with cubs is used to coming to this river at the same time because that's what her mother did, and her mother's mother, and so on for thousands of generations. But if the water gets warmer, the salmon might arrive earlier or later. If a mother bear with 2 hungry cubs arrives at the river at the usual time, but the salmon passed 2 weeks ago or hasn't arrived yet and won't come for another 3 weeks, the cubs miss out on food when they need it most. This isn't a Hollywood disaster with tsunamis and explosions. It's a quiet schedule disruption that kills slowly, 1 cub per season, 1 family per generation. The second threat is industrial, and it has a specific date that everyone in Kamchatka remembers. In the fall of 2020, something happened off the coast of the peninsula in Avachinskaya Bay, the main bay of Petropavlovsk-Kamchatsky, the only major city on the peninsula that still makes locals' stomachs churn. A mass die-off of marine organisms. Surfers entering the water suffered chemical burns to their eyes and skin. Dead octopuses, sea urchins, and crabs washed ashore. The water changed color. The smell was so bad that it was hard to approach the shore. This story made global headlines, and an investigation began. Dozens of theories were considered. A leak of rocket fuel from military depots, illegal dumping of industrial waste, a bloom of toxic algae possibly triggered by abnormally warm water. A definitive answer was never found. Some scientists lean toward the toxic algae theory, while others believe chemical pollution played a role. But the fact remains, one of the cleanest bodies of water in the country, where salmon return after years in the ocean, was poisoned, and no one could say exactly what caused it or why. The third threat is the oldest and most mundane of all: poaching. Illegal salmon fishing in Kamchatka isn't just two guys with fishing rods on the shore. It's an organized industry with nets, boats, processing equipment, and distribution channels. Some estimates suggest that the volume of poached fish could be up to a third of the official catch. This means that for every 3 fish caught legally, 1 is caught illegally. And this illegal catch impacts the ecosystem in 2 ways. First, it reduces the number of salmon that reach spawning grounds and produce offspring. And second, it decreases the amount of fish that die after spawning and nourish the forest. Each fish intercepted by a poacher downstream means 130 grams of nitrogen and 20 grams of phosphorus won't reach the soil. Multiply that by millions, and the scale becomes clear. But if it were only about threats, this story wouldn't be worth telling, because stories that end with everything is lost don't change anything. They evoke despair, and despair paralyzes. So here's another part of the truth, the one that gives us reasons not to give up. The Kronotsky Nature Reserve was established in 1934, and today it protects over 11,000 square kilometers of Kamchatka land. Within its borders lies the Valley of Geysers, the caldera of the Uzon volcano with hot springs and thermal lakes, and dozens of rivers where salmon spawn under legal protection. There's no industry, no extraction, no development in the reserve. It's one of the largest protected areas in Russia, and it works. The bears inside the reserve feel so safe that they allow people to come close enough to take pictures without a telephoto lens. The South Kamchatka Federal Wildlife Refuge protects Kuril Lake, the very place where millions of sockeye salmon spawn and where dozens of bears fish simultaneously. This refuge exists precisely to keep the most productive spawning ground on the peninsula untouched, and so far, it's fulfilling its mission. In recent years, ecotourism has begun to develop in Kamchatka, and surprisingly, this is one of the most encouraging pieces of news. Bear watching at Kuril Lake has become a tourist attraction that brings real income to local communities. And when a living bear catching fish generates more revenue than a dead bear or an empty river, locals have an economic incentive to protect rather than destroy. This isn't idealism, it's simple arithmetic. Tourists pay for helicopter tours, accommodations, guides, and entry permits. This money stays in the region. And every bear, every salmon, every geyser becomes not a resource to be exploited, but a resource for earning income in its living form. Kamchatka has already proven it can recover. In 1964, the Shivaluch volcano produced one of the most powerful eruptions of the 20th century. Ash and rocks covered the surrounding area for miles. It seemed that life on these slopes wouldn't return for decades, but it did return. First came the lichens, then the mosses, then the grasses, then the shrubs, and finally the trees. Bears returned to these slopes, foxes dug new dens, and eagles built new nests. The land healed its wounds because the pressure didn't exceed its resilience. And this is the whole question. It's not about whether Kamchatka is resilient. It is resilient, as proven by geological history and biological practice. The question is whether the pressure humans exert on it will exceed the limit beyond which recovery is impossible. Glaciers may melt, but if they melt past the point of no return, rivers won't recover in a single generation. Salmon can survive a bad year, but if bad years become the norm, the population will decline, bears will go hungry, forests will lack nutrients, and the cycle that has turned for millennia will come to a halt. Fire, water, fish, beasts, forests. 5 elements, 5 links in one chain. Each depends on the others. The volcano creates land. Water carves it into rivers. Fish bring the ocean into these rivers. Beasts carry the ocean into the forest. The forest holds the riverbanks where the next generation of fish is born. And all of this turns on its own, without guidance, without a plan, without a project manager, simply because each element does what it was meant to do. Humanity's role in this system isn't to manage it, not to optimize, improve, or restructure. The task is simple yet incredibly difficult. Just don't break what works without us. Kamchatka manages on its own. It has managed on its own for thousands of years before us, and will continue to manage for thousands of years after if we let it.